Hello everyone, and welcome to OCI Operations. This is Automation Tools. My name is Eli Schilling. I am a member of the OCI Product Management team. Now to kick things off with this module, we are going to dig into the OCI CLI, the command line interface. And this is one of the most essential tools for managing and automating our Oracle Cloud Infrastructure ecosystem. As previously mentioned, this is written with the Python SDK. It is compatible with Python 2.7.5 or newer and 3.5, keeping in mind that Python 2.7 will be soon deprecated. And as a matter of fact, this tool will run on Mac, it'll run on Windows, and it works on Linux as well. Now, the CLI itself is a fairly straightforward command construct. OCI being the commandlet. And then when we want to interact with a particular service or feature, we specify first the service, followed by the component name and the action we wish to perform. So in this case, OCI compute instance list. This will return a list of all compute instances in a designated region and compartment. Now, every command also includes the option for command parameters. This allows us to define things like a given availability domain, a specified region, a different compartment that we choose to use at runtime. We can also sort or limit the number of responses with these optional command parameters. And we'll look at a few more examples as we go. To get started, we first need to install the CLI. This can be done quite simply using a pre-built set of commands both available for PowerShell on Windows and for the terminal prompt on Mac OS or Linux. Once the installation is complete, we need to provide authentication credentials so the CLI can interact on our behalf with the OCI API endpoints. To do this, we'll simply execute the command OCI setup config, and we will be prompted for a series of credentials. Let's go ahead and jump into a terminal session and take a look at this process. So here we will run OCI setup config, and it's going to inform us that we're going to walk through the process of creating a valid CLI config file. First, let's choose the home for this file, and we're just going to accept the default location. Next, we'll enter the OCID for the IAM user that we're choosing to set as our authentication principal. Next, it's going to ask for our tenancy OCID. We need to select our preferred home region. Now, even though this single region is set into our config file, as we saw with the optional command parameters, we can always override that region at command execution. So for this, let's just use Phoenix. Now finally, it's going to ask if we want to generate a new API signing key or if we have an existing key already. I actually have a key that's already been created, so I'm going to say no, and it's going to ask for the location of that key. So I'll just use the API signing key that was previously created, and there we have it. It has created for me a config file in my home directory. So if we want to take a look at what that shows, it's just a very simple, I have a default profile with a set of credentials that correspond to my account. Now to test this, we could do something like OCI IAM availability domain list. What this is going to do is simply list all of the availability domains within the current region, which is Phoenix, the one we set. And again, if we wanted to quickly test a different region, we could simply use the command parameter region, change it to Ashburn, and execute. Now this is only for the one command execution. If I ran the command again without the region parameter, it would return to the default that I'd set in my config file, which is Phoenix. You can see here all of the Ashburn availability domains listed. Now the next component we'll take a look at are the OCI CLI profiles. Within the file that we created initially was the single default profile. we can create additional sections for different users. This allows us to store multiple sets of credentials in the config file and easily change the set of credentials at runtime by simply specifying --profile along with the name of the profile that we've defined in our config file. So if we're utilizing different sets of credentials, one perhaps with access to compartment A, a different with access to compartment B, perhaps you're managing multiple tenancies and need to use different user credentials to access different environments or different customer applications. This simplifies the process so that you don't have to go and add or change credentials every time you need to switch the environment in which you're working. Now, as an example, the CLI can be used to script or automate common tasks, as we discussed in a previous module. Here we have a very simple script that is using the CLI to create a compute resource. So we're launching a new compute resource. Once that resource is up and running, we are retrieving the public IP address of that resource in order to perform some testing. Now, the next section here is going to do a very rudimentary SSH validation. SSH is generally one of the final services to start in the Linux OS when the new machine is booted. So it's a fairly reliable way to make sure that the system is accessible before we move on to additional tests. So we're going to loop until we receive a valid response to our SSH connection request. Once that loop succeeds, we can move on to performing a series of automated tests. So if this is something where every day or several times a week you're asked to stand up a new server, deploy some code, and then run some tests, a simple script like this could allow you to fully automate that process. Then you could simply execute the script manually when necessary, or it could even be scheduled using a job scheduler or something like cron within the Linux OS. Now, the next topic here is infrastructure as code. And we're going to spend some time talking about Terraform, which is the chosen tool for infrastructure as code on top of OCI. Terraform, of course, is an open source tool. It's built and maintained by HashiCorp, and it utilizes the notion of providers to perform platform level interpretation. So I would use an OCI provider in order to interact with the OCI ecosystem. Now, Terraform can also be used to export existing environments. So if you've deployed something manually within OCI and you would like to take that environment and begin to manage it with Terraform, you can use the Terraform discovery feature to export those resources into a Terraform configuration. You can retrieve the Terraform state along with that, and then begin to manage that environment exclusively through Terraform. Now, Terraform is infrastructure as code. It's predominantly designed for deploying and managing infrastructure. So oftentimes, companies will couple this with a configuration management tool like Chef, Puppet, or Ansible to maintain the environment after it's been deployed. When I say maintenance, I mean things like patching, application deployment, and other configuration changes that might be necessary during the life of that environment. Now, we'll take a quick look at the Terraform Provider here. And this is also a sample of the Terraform configuration. So the first thing we have to do is specify the provider name, along with a requisite set of variables that will define how we authenticate and connect to this OCI environment. So very similar to the OCI command line interface, we're going to specify the tenancy, the user, and the private key, along with the region. This enables Terraform to construct the appropriate API assertions on our behalf as it interprets our infrastructure code and converts it into actual infrastructure. Now, within Terraform, we also have the notion of data sources. And data sources are sort of like little query tools. So if I have existing resources or simply need to evaluate some of the core components within OCI, these data sources can be used to query things within my environment. So in this very simple scenario here, I'm using the availability domains data source, and I'm simply going to look at all the availability domains available in the given region. So if I were to query this and produce an output, on my screen it would actually print the details of my availability domains. Now let's jump into the terminal and take a quick look at some Terraform commands and an example of this exact scenario here. Now let's start by taking a look at that Terraform configuration. And you can see it's fairly similar here to what we looked at on the slide. We're going to specify the provider variables. We will also specify the data source, and then we're going to output the 3 availability domains, or the name of them, within this particular region. Now, the first thing we're going to do with Terraform, once we have our configuration all set, is initialize. So I'll run Terraform init to initialize our credentials and configuration. And it's going to go through and indicate we have the OCI Provider. It's going to be using 3.37, and Terraform has been successfully initialized. Now the next step would be to run Terraform plan, and this is going to show us what would be created or changed or even destroyed if we were to execute our configuration. Now in this case, we're simply working with a data source, so there are no changes to be made to the environment. Therefore, we can proceed and Terraform apply. What this is going to do is look up, using that data source, the availability domains in the given region, and the output returns the value of those 3 availability domains. Now the next topic here is Ansible. From a configuration management and also infrastructure as code perspective, Ansible is meant to be simple. It's human readable automation. There's really no software development experience necessary in order to use Ansible. It's a pretty powerful tool because it can handle both application and infrastructure deployment. As we mentioned earlier, it does the configuration management for our environment once that environment has actually been provisioned. And one of the most popular notions of Ansible is that it doesn't require an agent. It uses OpenSSH or WinRM to communicate with all of the target hosts. This helps to simplify your deployment and management of the environment. It also means no agents to exploit or agents to update on all of your hosts that are being managed in the environment by Ansible. Now, Ansible is really designed for system administrators, DevOps engineers. Sometimes we say that the site reliability engineering team would use this as well. And it's often incorporated in a DevOps toolkit. So as we think about the whole end-to-end life cycle of infrastructure and application, Ansible plays a critical role in facilitating the automated delivery and management of the resources in our application stack. So as we've mentioned, it not only does configuration management, but it can also deploy and destroy infrastructure resources. It works for one-off batch or command execution. So if you needed to quickly ping or test connectivity or start or stop services on a whole collection of hosts, Ansible works great for that ad hoc style command execution. Using playbooks, we can automate complex orchestration flows. So executing a series of different configuration and deployment activities within a single collection of workflow. And it helps to, again, manage application deployment, release management, auditability, and overall control of our application ecosystem. Here we have a very basic example of an Ansible playbook. So this is a procedural style configuration management tool, and it uses a format known as YAML, or as I like to say, yet another markup language. So YAML basically defines the format of the file, and here we simply specify a number of parameters. So we'll give our task a name, and we'll specify the scope. So Ansible uses the notion of inventory to track and manage collections of resources. So our inventory file, or our inventory database that Ansible is using, has a collection known as web servers, which might contain one or more actual hosts. So when this playbook is executed, all of the hosts defined within the web servers collection would be affected. Now we can have multiple tasks. So the first one here is to install Apache. We're just here going to make sure that Apache is present. So in this case, it's essentially idempotent. So we're not saying to install or uninstall, we're simply saying make it sure it's present. If it's there, we're done. If it's not there, we install it. End of story. And then finally, we want to make sure that Apache is running. So the next task is to ensure the state of that service is running. Now, if you take a quick look at these tools side by side, so CLI, Chef, Ansible, Terraform, some of the key things to keep in mind here are really around what the tools are best suited for and how the tools function in general. So as you mentioned, CLI is really good for automating simple repetitive tasks. As you start getting into infrastructure deployment and management, while it can be performed with CLI, it becomes very burdensome, very challenging to be able to create this and manage the scripts that would deploy complex sets of infrastructure. Terraform is great for that sort of thing, though. So when it comes to orchestrating and provisioning large, complex environments, Terraform easily solves that challenge. Now, Ansible and Chef both give us that configuration management layer, but as we discussed, Ansible can do so much more than simple configuration management. Now, another strong consideration here is the method. And we're going to compare Ansible and Terraform here specifically for a moment. Ansible is a procedural tool. That means we define step by step what we want to have happen. So if I want to install Apache, start Apache, deploy some sample HTML, etc., my Ansible code is going to basically have that step by step defined. Terraform, on the other hand, is declarative, which means I specify or I declare what it is I want, and Terraform will go and create what it is that I want. Now, with that, Terraform also provides state management. And what that means is we declare what we want, Terraform creates what we want, and then Terraform tracks what we have. So if I need to make a change to an environment that was created with Terraform, I would simply alter my Terraform configuration. Terraform would determine the difference between the state, what we currently have, and what I've declared, what I've changed in my configuration. And then Terraform would take action to make the environment, the state, look like what we've now defined. So in closing, when we are automating simple repeatable actions, the CLI is a fantastic tool for that. If we're managing app deployment and configuration, think about using tools like Ansible or Chef. And when it comes to creating, managing, and destroying complex application architectures, Terraform is really the way to go. Thanks for watching, folks. That has been an introduction to automation tools on OCI. Come back again, and we'll see you at the next video. Thank you.